This is the 7th video in my indoor weather station tutorial series, and here I just want to go over a couple of wiring basics and also just explain to you that, well, if you've been following from the beginning, you'll know that in the end I want to hook up all these 7 different environmental sensors and have them reading simultaneously. In the next 7 videos, I'll be going through each sensor individually. I'll upload the code to be able to test each sensor individually and show how to wire each sensor individually. If you'd rather like to skip ahead to the point where we hook them all up at the same time and execute a code that reads all of them at the same time, then you can skip ahead to video number 15 where we'll be doing just that. Now, what we'll be trying to do is connecting these pins of the sensors to these pins from the Raspberry Pi. Here, each pin is usually described, so GND, do we have it here, means ground, for instance. And there are also some usually online tutorials or online resources for each of the sensors that go into more detail. With the Raspberry Pi, there are no labels here. But what you can do is Google something like Raspberry Pi GPIO or Raspberry Pi pinout, and it'll give you a sort of mapping of which pin means what. And so, for instance, the top left one here gives you a 3.3 supply voltage, and the top right one a 5 volt voltage. Remember, I described in an earlier video that I want to be able to solder or attach the Raspberry Pi to the top of a perf board. That's why I soldered the headers on at the bottom. You might have them at the top, but that doesn't really matter. So your top left one still has this 3.3 supply voltage. We could take the sensors and just use female jumper cables to connect, say, one of these pins to the appropriate pin on this end. The thing is that some of the sensors, like this one, need an additional component in between the Raspberry Pi and the sensor, and then it starts getting a bit complicated with the wiring. So that's when we use this breadboard, basically as an interface between the two. The way this works is that if we just look at these rows of slots, each slot in a row is connected to one another. So if I put a wire in A1 and E1, now my fingers are connected. If I just move this one by one row, not connected anymore, there's a physical barrier between the rows. There's also a physical barrier here, so if I put this into F, also not connected. Here, it's the other way around. So here, the rows are not connected, but the columns are. So now my fingers are connected. And in this case, the entire column is connected, so I can put it right down here, and my fingers are connected. Again, there's this physical barrier in between, so not connected. And the advantage of using this, especially if we have several sensors, is that we can do something like this, where we place several sensors here. So now we have a row for each of the pins. And both of these pins need a 3.3 supply voltage. So we would, for instance, take this and attach it to this column. And now our plus column is entirely supplied with supply voltage. We can then use a ground pin and connect it to the minus, for instance. And now this entire column is grounded. So that means now we can supply each of these sensors individually with supply voltage and with ground. And we can do the same for this guy right here. And that just makes it all a little bit easier, especially if we have several sensors. So anyway, I hope that helped. If you like this video, please like and subscribe. And I will see you either in the next 7 videos or, like I said, in video number 15. See you then.